So this is a Discflo pump. It looks like an in-suction centrifugal, but on the inside is a disc pack. So right inside of this pump is this disc pack right here. That's what's doing all of the pumping. The principle of operation is boundary layer and viscous drag. So as fluid enters the eye of the disc pack rotates, the liquid sticks to the disc, rotates at the same speed, and drags the next layers with it. So it's smooth, laminar flow, non-pulsating design. We have no tight clearances. We have an 1/8 of an inch front and back of our disc pack. And in the pumping world, an 1/8 of an inch is a mile wide. So no tight clearances combined with boundary layer viscous drag. The boundary layer does two things. It protects your pump from damage by the product. So we pump very abrasive materials with little to no wear on the pump itself. The fluid that's moving in the highest velocity zone is away from the disc surface. All of your abrasives that would be near the disc are in the low velocity zone, so there's no wear. We also handle very shear sensitive materials. So polymers, crystals, we don't damage the flock of wastewater for dewatering. So all of your shear sensitive material moving in the center away from the disc surface. In addition, there's no blades or vanes to chop it up. So in a centrifugal design, you would have, the product would get chopped up as it enters the pump and chopped up as it exits. With our design, we have no shear at all. So it's smooth laminar flow, non-shearing, non-pulsating design. Because we're laminar flow, non-pulsating, we have very little radial and axial loads. So our bearings last longer, our seals last longer. So as long as the product can flow into the pump, we can pump it out. We size the discs and the spacing according to the solid. So we can have the discs, 1/4 inch apart, and we can have them 12 inches apart to handle large solids.